Scientists like to classify things. We understand and learn about the universe by grouping things and seeing how are they alike and how are they different. So you'll find as we go through the semester that we do a lot of classifying of things. So we can classify matter by its physical state. There are 3 physical states of matter: solid, liquid, and gas. Water is nice because we are familiar with water in all 3 physical states. What do we call water in the solid state? We call it ice. Ice is just frozen water, right? And liquid water we just call water, and in the gas state, what do we call it? Steam. Okay, and so we have encountered water in all 3 states. If we zoom in and look at the molecules of water, they kind of look like little Mickey Mouse heads, don't they? Little red and white Mickey Mouse heads. Notice that the particles are the same in each of the 3 states. The particles haven't changed. What changes is how the particles interact with each other. In liquid water, the particles are very close together, but they're moving around. They're free to move around. In the gas state, the particles are farther away from each other. In the solid state, the particles are close together, but now they're not moving relative to each other. So this is a little bit like students. We can do students or cows. Which do you prefer? Because it's Tulare, right? We'll do cows. If you want the student one, you can listen to one of my old lectures. The 3 physical states of cows, okay? So the solid state for cows would be like when you have them in the barn in their individual stalls, right? So here's Bessie, and here's, what's another good cow name? Buttercup, thank you. Bessie and Buttercup. Bessie and Buttercup are in neighboring stalls. And so they're always going to be in the same position relative to each other, right? Buttercup cannot go down a few stalls and stand next to somebody else. She has to stay in that stall. The water particles in the solid state are frozen in position, right? They have to be next to each other. Are those cows, though, in their stalls completely motionless? No. They're switching their tails, they're looking around, they're mooing, they're shuffling their hooves, they're fidgeting, right? Water molecules, even when they're frozen, are not completely still. They're vibrating, just like cows in their stalls. So the liquid state of cows, what do you think that would be? Be like the feedlot, right? When I'm driving down here, sometimes I take Alta, and you go past the feedlots, and there's a whole bunch of cows, and they're all close together. But they're not organized in any way, are they? They're just in one small corral, and they can mill about, but they're close to each other. So these water molecules, they're penned in, they're in close quarters, just like they were over here, but now they can shift around. And if Elsa, where did Elsa come from? Bessie. I was thinking Frozen. Frozen the movie, Elsa, Frozen. And it was Bessie and Buttercup. Now, if Bessie and Buttercup are tired of each other, they can get away from each other, right? Buttercup can move to the outside of the herd, but she can't get completely away from the other cows because there's a fence there. They're stuck in this area. The gas state for cows would be when you send them out on the open range. And they can go off in all kinds of different directions, and they don't have to see each other at all. Cows don't necessarily do that. They tend to kind of hang out together, but molecules don't do that. They're far apart from each other. They're moving independently. Okay? So 3 states of matter, 3 states of cows. So then these next slides I've already kind of covered. In the solid state, we've got the particles packed close together. Important concept here, they're close. No, that's not a good color. Let's go with the green highlighter. They're close, and they're fixed locations. The particles are vibrating or oscillating, but they don't move relative to each other. Solids have a fixed volume and a rigid shape. If you take an ice cube out of the ice cube tray and you put it on a plate, does its shape change? No. The shape remains the same. That's what solids do. The volume is also the same. There are different kinds of solids. I told you we were going to classify things. We can classify solids by how the particles are organized. So in a crystalline solid, the molecules or atoms are arranged in a pattern. So this is an illustration of a crystalline solid. This would be like the cows, and they're in their rows in the stalls, right? So everybody's lined up, all very nice. An amorphous, A is a prefix that means without, and morphous has to do with shape. When a superhero morphs, what do? They change their shape. Amorphous means without shape. So there's no organization. So now we really can't stay with the cows here. We're going to switch to kindergartners. Crystalline kindergartners are sitting in rows in their desks, close together, fidgeting absolutely, but organized in rows. Amorphous kindergartners are when they come up to the rug for circle time to listen to a story. They're sitting down, they're not moving relative to each other, but they're not organized anymore, right? They're still fidgeting. Kindergartners always fidget. I have one, I know. Okay? So there's no long-range order. Liquids. Important ideas about liquids. The molecules are close to each other. That's the same as in a solid, but they're free to move around. They don't have to stay next to each other. Liquids also have a fixed volume. If you take a cup of water and pour it into a tall, skinny glass, and then take and pour it into a large, shallow bowl, does the volume change? No. What changes? The shape changes. So the volume is fixed, but liquids assume the shape of their container because the particles can move around. So there's similarities between liquids and solids, and there are differences. In the gas state, the molecules are separated by large distances, and they are free to move relative to each other. So one of the things that makes gases unique is that gases are compressible. If you take a solid and put it in a piston and squeeze down on it, you can't compress it. You're not going to be able to push this plunger down at all. If you have a gas in here and push down on it, you can squeeze the gas particles closer together. Because what is between these gas particles? Air. Well, that's a very reasonable idea. But what is air? Air is gas particles, and what's between the particles is absolutely nothing. Space. Empty space. That's why we can take air and we can compress it and make it smaller. So we're just squeezing the particles closer together. There's nothing to squeeze out because nothing doesn't take up space. So gases are compressible, and they always assume the shape and the volume of their containers. If you have a small container of gas and you transfer it to a large container, it will expand and fill the volume that it has available. It's a little bit like work. Work expands to fill the amount of time that you have to do it in, right? That's why we sometimes wait till the last minute, because then we only have a certain amount of time. We get it done really fast. The gases expand. They take the shape and the volume of their containers. So those are properties of these three states of matter that you need to know. Here's a summary of that. So that's a nice table. I'll let you read that yourself.